In this video for section 5.2, we're going to talk about the binomial distribution. The binomial distribution is used when we have situations where trials have only two possible outcomes. Usually it's a yes or a no, or something happens or it doesn't happen. Sometimes they're called success and failure, although we won't really see that language much. The number of trials and probability of success are fixed, and they are given to you in the problems. We're going to use Minitab to calculate probability values for these. So let's look at example 5.4. A major airline believes that 80% of its customers favor changing from assigned seating to choosing seats on a first-come, first-served basis. A random sample of 20 customers is taken. What is the probability that 12 or fewer customers like the proposed change? So some of the important information in the problem is the probability, which is 80%, the number of trials, which is 20, and the question is asking for the probability that 12 or fewer customers like the change. So when we do this, we are going to use Minitab, and we are going to go to Graph, and we are going to go down to Probability Distribution Plot. We are not entering anything in the spreadsheet part of Minitab for these problems. Click on View Probability and click OK. Now we change the distribution from normal to binomial, which is all the way up at the top, and we enter the number of trials and event probability from the problem. So my event probability was 80% and I had 20 trials. When I enter the event probability, I enter it as a decimal, so 0.80. Then I click on Options. Now what the question is asking me is what I use to fill in this menu. So going back to my question here, I wanted to know the probability that 12 or fewer customers like the proposed change. Now 12 or fewer means that it could be 12 or it could be less than 12. It could be 11, 10, 9, or 8, or 7, 6, 5, 4, 3, 2, 1, or 0. So when we're doing these problems, we want to think about whether this number is included or not included. And in the instructions that you find in Blackboard for calculating these in Minitab, you will see some help with the language here that tells you what to choose. 12 or fewer would be less than or equal to 12, and so it would be the same as this one here. We're going to choose left tail, and in the X value box, we enter in whatever this number is. So that's going to be 12. So when you're thinking about this, when I'm thinking about left and right tail, kind of think about a number line. Numbers that are smaller are on the left, and numbers that are larger are on the right. So like if I look at where this red part starts, that's going to include everything in left tail that's less than that. Right tail would include anything that's greater than that. So we're going to change this to specified X value. We're going to select left tail, and our X value is going to be 12. Then we click OK, and click OK again. Here is my result. So it's giving me this graph. I see my N and my P up at the top. I should verify that those are correct. And then here, the red shaded boxes indicate the area that is 12 or less, 12 or fewer. And so I can also check that to make sure that that matches up with what I want for my problem. My answer, my probability, is written above the red boxes. And so I can see that right here, 0.03214. So I want to pay attention in a homework problem to where I want to round that number. If it was 4 digits after the decimal point, that would be 0.0321. So I would write that for my answer, or type it in the case of a homework problem. And so that's not very likely to happen because it's only a probability of about 3%. So remember, with probabilities, numbers closer to 0 are less likely or not very likely. Numbers close to 1 are pretty likely to happen. So this is not very likely to happen. So we can also find expected value and standard deviation. And we don't use Minitab for this. We use some formulas, and luckily the formulas are pretty simple. So the expected value formula, we multiply sample size times probability, N times P. And this is something that kind of should make sense. So if I look at this question, a major airline believes that 80% of its customers favor changing from assigned seating to choosing seats on a first-come, first-served basis. A random sample of 20 customers is taken. What is the expected number of customers who would like the proposed change? So really, it would be 80% of the 20 customers is what I would expect to be the number who would like the proposed change. And 80% of 20 is just 80%, or 0.80 times 20. So that formula should kind of make sense what you're doing there with that. So my expected value is n, which is 20, times p, which is 0.8, or 0.80. And if I multiply those, I can use a calculator and I get 16. So 16 customers is what I would expect for the number who would like the proposed change. We can also calculate standard deviation. The formula is only slightly more complicated than the one for expected value. This is square root of n times p times q. N and p are the same as before. N is sample size, p is probability of success, q is 1 minus p, and that's considered to be the probability of failure. So for this problem, if I want to calculate the standard deviation, I would do square root of n, which is 20, times p, 0.8, times 1 minus 0.8, which I know is 0.2. So I can type this into my calculator like this, or I can do the 1 minus part separately if I want to. But either way, when I type this in, I should get 1.7889. And again, pay attention when you're doing the homework problems to how you should round this number. And that's how you calculate probability, expected value, and standard deviation for a binomial distribution.